Hello everyone, we are Group 3 and this is our video presentation. These are the following group members: Lin Hei Tong, Se Long Wai, Mak Wing Yan, Ma Cheng, and Wu Yut Tong. Today we are going to discuss about the Mock 3 question number 3. And I'm Wu Yut Tong. I'm going to discuss question 3A. The daily sales amount of a cake shop is normally distributed with a mean of $10,000 and a standard deviation of $2,500. So, part A1. What is the probability that the sales amount of the cake shop is between $7,500 and $14,000? So first step, let X be the sales amount of the cake shop. Second step, we know that the mean is $10,000, while the standard deviation is $2,500. Third step, we have to find out the probability between $7,500 and $14,000. So, here's the calculation. We have to find out the probability between 7,500 and 14,000. Since X is a normal random variable with mean and standard deviation, then it is a standard normal random variable. By using the formula X minus mean over standard deviation, we will find out Z. So, for 7,500, we will minus mean, which is 10,000, over standard deviation, 2,500. We will find out -1. By using the same method on 14,000, we will find it is 1.6. According to the table of standardized normal distribution, when Z is larger than 1, the probability of the area is 0.1587. When Z is larger than 1.6, the area of the probability is 0.0548. So, we have to minus the area of Z larger than 1.6 and area of Z smaller than -1, which is 1 minus 0.0548 minus 0.1587, and find out Z is equals to 0.7865. So, the probability that the sales amount of cake shop between $7,500 and $14,000 is 0.7865.
Good afternoon, everyone. My name is Lin Hei Tong, Rachel. Here comes to the second question, still in the same page. Question 3A2. First, let's read the question together. Determine the daily sales amount such that 90% of the days are having sales amount more than it. This is the calculation. Let M be the events that the daily sales amount such that 90% of the days are having sales amount more than it. The required probability is X greater than M equal to 90%. Next step is Z greater than M minus 10,000 over 2,500 equal to 90%. When M minus 10,000 over 2,500 is similarly equal to -1.28. Therefore, we can know that M is equal to 6,800. Thus, The event sets the daily sales amount such that 90% of the days are having sales amount more than it is 6,800. That's the end of this question. Thank you.
Hello, I'm Macklin Yan, and I'm going to talk about the question B1. For question 3B, which is on the page 213, our community center is going to hold a yoga class with 15 registered students. From the previous records of yoga class, the average absence rate per student is 5%, and the question B1 is asked to calculate the probability that at most 13 students will attend the yoga class. First, we have to identify which distribution that this question belongs to. We can see that this is a binomial experiment, as it fulfills the 4 properties which a binomial experiment has. The first condition is that there should be n identical observation or trials. In the case, there are 15 registered students. For the second one, each trial only has 2 possible outcomes, while this question only has attend or absent these 2 possible outcomes. For the third condition is the probability remain the same for all trials. Refer to the question, the average absence rate per student is 5%. The last one is the outcome of all trials are independent of each other. Hence, this question follows a binomial distribution. And we can start to calculate the question by first let x be the number of students who will attend the yoga class. Then we have to find the probability of students who attend the yoga class, which is 1 minus 5%, that is 0.95. Thus, it follows a binomial distribution of 15, 0.95. The probability that at most 13 students will attend the yoga class will be equal to the probability of x smaller or equal to 13. In order to calculate it in a more simple way, we can have 1 minus the probability of x greater or equal to 14. And then the next step is 1 minus the probability of x equal to 14 minus the probability of x equal to 15. Then, in order to calculate that 2 probability, we have to apply the formula which is shown on the right hand corner. And we have 1 minus 15 combination of 14 times 0.95 to the power of 14 times 1 minus 0.95 minus 15 combination of 15 times 0.95 to the power of 15. Finally, we can calculate the answer, which is 0.1710.
Like the first part, the number of students who attend the yoga class follows a binomial distribution, as the probability of absence in different students is the same, and student absence is independent with each others. The probability that at least 12 students attend the class, which is denoted as x is greater than 12. The probability that at most 1 student is absent is the same as the probability at least 14 students attend the class, which is denoted as x is greater than 14. So the required probability is x greater than 14, given that x is greater than 12. To solve this, as we now know that the required probability, and we know that the conditional probability is equal to the intercept of 2 events divided by the conditional event. So we have to find out the intercept of 12 more attendance and 14 more attendance. From the Venn diagram, we know that 14 more attendance is fully enclosed inside by the 12 more attendance. So actually, the fact is that the intercept would only be the 14 more attendance. With this piece of information, we can compute both required probability using the binomial theorem. The numerator would be the probability of x is greater than 14, which is the binomial distribution when x is equal to 14 and 15. The denominator would be the probability of x is greater than 12, which is the binomial distribution when x is equal to 12, 13, 14, and 15. By calculation, we can get the answer 0.8836.
Good afternoon, everyone. My name is Jean. Here comes to the last question. Still in page 213, question number 3, C. First, let's read this question together. The number of a new model of high-definition television sold in electric shops follow the Poisson distribution with a mean rate of 10 per day. In order to solve this question, we first need to identify the key words and the most useful information in this question. That is, the number of televisions follow the Poisson distribution with the mean rate of 10 per day. From this piece of information, we can get this. Then let's look at what this question is actually asking for. Calculate the probability that at most one day in the next 7 days will have at most 7 televisions to be sold in a day. From this question, we know that there are 2 conditions, and we need 2 steps in order to solve the problem. First, we need to know the probability of at most 7 televisions to be sold in one day. And this question should be addressed by the Poisson distribution that we get before. Then, in the second step, we can use the result that we get in the first step to finish the whole question. Okay, now let's see the detailed steps of this question. Still, let's define the variable first. Let A be the event that at most one day in the next 7 days will have at most 7 televisions to be sold in a day. Let B be the event that at most 7 televisions to be sold in a day. As we mentioned before, in step 1, we need to find the probability of event B. We've already know that this follows the Poisson distribution, so we can use a notation and formula like this to get the result of event B. That is 2.22022. After finish step 1, we can forward to step 2. Find the probability of event A. After analysis, we know that this variable actually follows the 4 properties of binomial distribution. That is, there are n identical observations or trails. 2. Each trail has 2 possible outcomes. And number 3, the probabilities remain the same for all trails. And number 4, the outcomes of trails are independable. So we can know that this variable actually follows the binomial distribution. Then we can use the notation and formula of binomial distribution to get the result. That is 0.5219. Thus, the probability that at most one day in the next 7 days will have at most 7 televisions to be sold in a day is 0.5219. Okay, that's all of the mock test 3, question number 3. Thank you for your watching.